All right, this video is going to be pretty short. I just want to show you how to do a few angle conversions and how to use this unit circle once you know what it is. So after the last video, you should be able to fill this unit circle out and get all of these angle measurements on there. So now we're just going to convert using the circle. So the first type is using the circle, which are numbers that are already on there. So there is no like trick here, right? 150 degrees, so I've just found that 150 degrees is right here, and that is the same as 5 pi over 6. 4/3 pi radians, so I'm just looking in my circle for 4/3 pi. That's right here. You might have, yours probably says 8 pi over 6, depending on how you counted. So just know that you may have to reduce some of these to find the ones you're looking for, but that is the same as 240 degrees. So if there's simple ones that are on the circle, that's really easy. You just find the ones that match and move on. Obviously, not all the ones that you do are going to be on the circle. So like looking at your circle, you should see that 200 and 3 pi over 8 are not on there. So because those are not on the circle, we have to use another method. So remember on the last one, we said that all the way around the circle was 360 degrees, or that's the same as going 2 pi radians. Or we simplified that to just say that pi radians in and of itself was the same as 180 degrees. So anywhere in here is like a conversion factor that you can use. So if you have 200 degrees, there's a few different ways to do this, and I'll show you both of them. One of them I'm going to just set up a proportion. So if I want to know what 200 degrees is, I'm going to say, well, 200 degrees, that relates to 360 because that's out of 360 degrees. And then I don't know what that is in radians, so that's what I'm asking myself. But I know that the whole circle in radians is 2 pi. And now if I wanted to solve this, I could just cross multiply, right? So I could cross multiply here, and that would give me 400 pi, and then cross multiply there, so that would be 360 times we don't know equals 400 pi, and then we would divide by 360 to get our unknown by itself, which is going to give me that my unknown is, now one thing, remember in all of these the pi stays, so keep the pi, don't use it in your calculator or anything, and then you're just going to reduce this fraction. So 40, that's the same as 40 over 36, which is, if you divide by 4, 10 over 9. So this is 10 pi over 9. So 200 is the same as 10 pi over 9. And you can kind of check yourself. Well, there's a few ways you can check yourself, but the biggest thing is 200 is just a little bit past 180. So this number that I'm looking at right here should be just a little bit bigger than 1, which it is. 10/9 is a little bit bigger than 1. Now, this is the way that I think you're going to prefer, and you can use it to actually check the other way also. Pi, you just said right here that 180 and pi were the same thing. So if you have a pi in your problem, you can just substitute this value for 180 degrees. Now, pi, you know the value of pi is 3.14, so I'm not saying that pi 3.14 equals 180. I'm saying that pi radians equals 180 degrees, which for you may not be much of a distinction, but just know I'm not changing the value of pi. I can substitute this though, so I can change this to say 3 times 180 degrees now over 8. Notice the pi has completely been replaced by the 180 degrees, and then you can just work that out with your calculator. And when I did that, I got 540 degrees divided by 8 equals 67.5 degrees. Make sure that you keep the degree and actually on this first one I should say radians at the top. Make sure you keep that there just so you remember like what units you're transferring things to or translating them to. All right, now this last thing is not really converting, it's finding similar angles. So angles that are in the well, let me just define some things. First of all, normally we have positive angles because we start here and we move clockwise. All right, these are going to be your positive angles. If you have something talking about a negative angle, that still means you're starting in the same point, but instead of going clockwise, or counterclockwise, you're going to go clockwise. So you're going to go backwards around the circle. So negative is clockwise movement. So for example, and let me erase this so I can zoom in and show you. Okay, if I zoom in here, and let's say that I want to do, I'm going to go down here in this bottom quadrant. Sorry, this is messy. If I want to do negative 30 degrees, 30 degrees, normally 30 degrees would be up one tick mark, and that would land you right here. You see where I am in yellow? So negative 30 degrees is going to go down and going to land you right here. So negative 30 is the same as 330 degrees. All right, so I wrote that little example out for you. Okay, coterminal angles are angles that end, so co means like the same, and term means to terminate means to end, right? So coterminal means they have the same end place. So for an example of that, and then I'll do two other examples, but just kind of a basic one. So think about, I guess I could think about like people doing the Olympics, skateboarding or snowboarding when they do their flips, right? You can do like a 360, which would be like one rotation, right? Or 720 would be another rotation. So that's ending in the same place. So like a simple example of that would be 360 degrees is coterminal with 0 degrees, like not moving at all, or with 720 degrees, which would be two rotations, right? The easiest way to find coterminal angles is to either go forwards or backwards around the circle one complete revolution. So for degrees, if you want to find a coterminal angle, let's say for 30 degrees right here, to find a coterminal angle, you could just add another 360 degrees to that, because that would be all the way around the circle. Or you could subtract 360 and go the other way. So for instance, like 30 is also coterminal with, we add 390 degrees, because 390 would be all the way at 360 plus 30 more, right? They would end in this same spot. Obviously, the equivalent to that in radians, since all the way around the circle in radians is 2 pi, the equivalent in radians is just to add or subtract 2 pi. Again, if you're doing any of this with your calculator for the radians, use the fraction buttons, but do not type in the pi part. Just tag it onto your answer at the very end.